So in today's lesson, we're going to learn about how to find the missing sides of similar triangles. But before we get to that, we need to know what it means to be similar. So the way you read this up here is to say triangle ABC is similar to triangle DEF. So this symbol right over here means similar. Now we saw before that congruent was shown by this symbol. That meant that every single side, every single angle was exactly equal. So for similarity, let's try and find out what exactly that means. Here I've got triangle ABC is similar to DEF. So I know that these two triangles are similar. What do I notice about it? Well, first of all, I've got some matching angles. 120 is equal to 120. 35 is equal to the 35 here. And the 25 is equal to the 25 here. So I've got that all my angles are equal, but my sides aren't equal. But if I notice that this side, this triangle here, DEF, looks like it was originally ABC, but then it was rotated, translated over here, and then dilated to be something smaller. Well, if I rotate and translate ABC, if I rotate it around this way, I'm going to notice that I've got the side between angle 120 and the 35 degree angle, and the side between angle 120 and the 35 degree angle. That's the 4 side matching up with the 8 side. If I keep doing it this way, the longest side on this one matching up with the longest side here, that is my 8 side matching up with my 16 side, and then finally I've got the 5 side matching up with the 10 side over here. Well, what is the scale factor going between each of these sides from DEF to ABC, or the other way around from ABC to DEF? If I notice to go from 5 to 10, I could multiply by 2. To go from 8 to 16, I can multiply by 2 again. And guess what? For that final one, 4 to 8, 4 to 8, again, I've got that same scale factor of 2. So to be similar means to have every single one of your angles matching up, but then also for your sides to be proportional, which means essentially that I'm just using the same scale factor to go from each of the sides here to the corresponding side on this triangle. So once my scale factor is the same for all of them, and my angles are the same, that means that my two triangles are similar. So let's take a look at an example of that. Here, I've got two triangles. Now I can't do the sides that are proportional yet because I don't know if they're similar or not. But if I start solving for the missing angles here, I've got 113 plus 22 is 135, and 135 plus 45 gets me 180. So that missing angle there is 45. Now I've got 45 plus 113. Well, I know I had 45, 113. The last one's going to be 22. Likewise, this one over here is 22 degrees. So now that I have that all of my angles are equal, I have that these two triangles are similar, and I can write that down if I'd like to. I can say that, again, ABC, triangle ABC, is similar to triangle DEF. Now what I want to do is find the measures of the missing sides. So I've got the 12 matching up with the 18. So I went from 12 to 18 in those two triangles. I went from 4 to something, I don't know what. The 4 gets multiplied by the same scale factor, goes to something. And then finally I have something, because I'm always right now going from the smaller triangle to the bigger one, something is equal to the 9. So I have something multiplied by the scale factor gets me to that side of 9. Well, I know that just like when we saw Alice in Wonderland with her potion, I know that if I start with something, I'll use start, then I multiply by some scale factor, that gets me to my new height or new length. So I can just say, all right, I'm starting with 12. I multiply by some scale factor. I don't know what it is yet, so I'll say s as my variable, and that gets me to the new, which is 18. Well, I can just solve for s, which means I'm going to start with 12 times s, divide both sides by 12. 12 divided by 12 gets me 1, so I'm left with s is equal to 18 over 12. If I want to simplify that, I can just do 18 divided by 12, which is 1.5, you can see on the calculator, okay? So this is also equal to 1.5, which is my scale factor. If I want, I can reduce this, I can simplify this fraction into, instead of 18 over 12, if I divide the top and bottom both by 6, I'll get that this is equal to 3 over 2. All of these are acceptable answers for my scale factor. Well, so now I know that my scale factor going from 18 to 12 was to multiply by 1.5 or 3/2. So I'm just going to use that same scale factor for the rest of the ones here. 4 times 1.5, which is my scale factor. 4 times 1.5, I can plug that in. 4 times 1.5, that gets me 6. So I know that my new side over here is 6. Maybe I shouldn't have drawn that as a circle. It should have been an underline here, because I'm starting with something, I'm not sure what yet, and it's going to go to 9. Well, I know that my scale factor is 1.5, but it's kind of hard to see how I'm going to do this if I write it this way. But let's write it as an algebraic equation. I don't know the value of what I'm starting with yet, so I'll write that as x. I know I multiply it by my scale factor, just my start times my scale factor gets me my new length. So my start, I don't know what it is. I'll multiply that by that same scale factor that I used to go from here to here or here to here, which was 1.5. So x times 1.5, and eventually I know that I'm going to get to 9. Well, x times 1.5, that means I can divide both sides by 1.5. I'm left with x is equal to 9 divided by 1.5. 9 divided by 1.5. I get that x is equal to 6. And what was x? X was our original starting side length of DE. So I know that the side length over here is 6. So what we did is I determined that these two are similar. I figured out what the scale factor was to go from 12 on this side to 18 on that side, and then I used that scale factor to say, oh, well, the scale factor I found was 1.5, so then I just multiplied by 1.5 times 4 to get this missing side. And then I said, well, I don't know what I started with, but I'll just set up this equation over here to go from some unknown to 9 when multiplying by that same scale factor, 1.5.